Tonight we have a great speaker who will be talking to us about engineering baseball. Before we get to that, I just have one quick announcement. Coming up on Wednesday, November 29th, the Wednesday after Thanksgiving, we will have a speaker from the Discovery Channel by the name of Christine McKinley, who will give a talk called Physics for Rock Stars. So mark your calendar for that one coming up in just a month from now, or a few weeks from now. But today it's my pleasure to introduce Dr. Richard Puerzer. Rich is an associate professor of engineering and is the chairperson of the engineering department at Hofstra University, where he's taught since 1996. He's written on not only as an engineer, but he's written and lectured on a number of baseball topics. His work has been published in a number of books and journals, including 9, a Journal of Baseball and Culture, Blackball, and Spitball. He was the co-director of the 50th anniversary of the New York Mets Conference, which was held here at Hofstra University in 2012. And in 2018, he is teaching a spring course on baseball analytics in Hofstra's Honors College. Please join me in welcoming Rich Puerzer.
Thank you, Bob. Thank you, everyone. Thank you for coming out tonight. I look forward to talking to you for the next little while about baseball. We were lucky enough to work things out with the Dodgers and the Astros that they would go 7, so they were going to play later tonight. So I'm going to warm you up for the 7th game of the World Series by talking to you about engineering baseball, science, technology, engineering, mathematics, management, and the national pastime. So, baseball stays as America's national pastime. I love all sports. I watch all sports. I like football a lot. I like basketball, but I really, really like baseball. And baseball, to me, appeals in so many ways. It has such a long and deep history. It has such a interesting, it's always current. It's always something that we can look at and find new things in. And one of the things over the years that I've come to really like about baseball is the complexity of the game, the situation, the people, and everything involved. And when I look at baseball, I look at the history of it. This is a picture of the St. Louis Cardinals in my hometown of Metuchen, New Jersey, back in 1936, sitting at the YMCA before they played a game against Metuchen back then. I love this aspect of baseball, and I love modern aspects of baseball as well. So I'm going to talk to you about STEM, management, and baseball, and one of the reasons I'm going to talk to you about it is because baseball is really serious business. John Thorne is the official historian of Major League Baseball. He was here back in 2012 when we had the Mets conference and delivered the keynote address, and that was one of his messages. And it's serious business because, obviously, there's a lot of money involved in baseball. It's really a field, a lucrative field that you could get into if you're good enough, if you're lucky enough to own a team. But it's also serious business because we can look at what goes on in a baseball game and analyze it and pick it apart and look at it in a lot of different ways, like an engineer would. Like an engineer would take a look at a problem and try and fix a problem or solve a problem by looking at different aspects of that problem. And so I'm going to talk about some of these things today. So I'm going to lead off by just talking about some basic statistics. If you're a baseball fan, you clearly know a little bit about the history of baseball and how we measure baseball, for example, by looking at earned run average and batting average. And so when we look at earned run average, how do we calculate earned run average? We take the earned runs divided by the innings pitched times 9 for a pitcher over the course of a season, career even, and we look at how well they do. Now, if we look back in history, in 1968, Bob Gibson had an ERA, an earned run average of 1.12. If we look more recently this season, Clayton Kershaw of 2.31. Those are pretty good. If we look at batting average, we look at the number of hits that a player acquires, a player collects, over the number of at-bats. And in 1941, famously, Ted Williams was the last person to hit 400 with his 406 average. And this season, Jose Altuve, who's going to be on display later tonight, hit 346. Again, that's all good. But what do those numbers really mean? What is earned run average and what is batting average? Are they good numbers? Are they measurables? Are they, if you're really good, does that mean that you automatically win? No. Do they have any problems involved with them? Absolutely. So if you know anything about earned run average, you know that a reliever comes in and he might take over with bases loaded, but those runs aren't his responsibility even though he's pitching. So when we calculate earned run average, we have to adjust based on what's going on in the situation. Likewise with batting average. I have that specifically over at bats. At bats does not include walks. And so walks is obviously a skill that we need to consider and worry about. So again, are these good statistics? And we're going to talk about that in relation to a number of statistics today. So here's a list, a laundry list of good statistics, maybe. Good performance indicators, perhaps, but certainly measures that we use. And so again, there's earned run average and batting average and on-base percentage and slugging percentage, which isn't really a percentage. There's also more modern things like range factor and OPS, which is on-base percentage plus slugging percentage. There's something I'm going to talk about in a little bit, win probability added. We're going to talk about a lot of these things. When it comes right down to it, if you own a team, shouldn't you be looking at dollars per win? Wouldn't that be, a good measure? Isn't that something that we would want to measure? Perhaps. So we look at all of these things and we can ask, are these good performance indicators? So one of the things I'm going to get into in a few minutes is this. Are these things the kinds of things that we want to measure, that we can measure, and that we can use to run a successful baseball team? The other thing I'm going to talk about a little bit is managing a baseball team. So Casey Stengel somewhat famously said that the best way to manage a baseball team is to keep the guys who hate you away from the guys who are undecided. That's one way of looking at this. It's not so much the modern way of looking at managing a baseball team, but Casey was actually ahead of his time in many ways and not so much in many ways. But we're going to talk about management and how management works these days in Major League Baseball, and again, look at it from a special perspective. And the perspective that I'm going to bring tonight is by looking at engineering, or more specifically, my field, industrial engineering and baseball. And so I'm going to spend a few minutes explaining what industrial engineering is, because a lot of people don't actually know what industrial engineering is. Of all of the fields of engineering, it's probably the most poorly named field of engineering, or the most antiquated in its name anyway. And it's something that really, when people think, okay, industrial, that means you must work in a factory, that's really not necessarily true, because lots of engineers work in hospitals, and we make things work better there. So I'm going to talk about industrial engineering for a few minutes, and then tie it all in with baseball. How many of you know what industrial engineering is? Okay, I'm very glad that I'll be talking to you about what industrial engineering is for just a few minutes. So industrial engineering is the study of methods for the improvement of systems used in the working world. We try to make things more productive. We try to make things safer. We try to make things just work better. We are sometimes called efficiency experts. In the old days, that's really what the terminology that was used is, we were efficiency experts. And we try and look at systems and make them better, faster, and cheaper. And better, faster, and cheaper, obviously, if you own a business, is good for you. If you're a customer, it probably makes you happier. Now, think about that in terms of baseball. Okay, better is clear. Faster, sure, we can even think about that in terms of, running the bases or catching a fly ball or something like that. Cheaper? That's something that we'll talk about or touch on at least here and there. In my office, I have a bumper sticker that says that engineers make things, industrial engineers make things better. And so that's sort of how industrial engineers look at the world, is we try to take systems and make them work better. There are four main areas of industrial engineering. There is operations research, which is the mathy part. I'm going to talk about that today with regard to baseball statistics. There is ergonomics, which is the looking at the human body and how it fits into a system and how it can be safe and comfortable and effective in that system. And we're going to talk about that a little bit with regard to things like pitching and batting. Management. Just like a baseball manager manages his team, you have plenty of other managers who manage his or her teams within a company, and I'm going to touch on that and how it relates to baseball. And then, in general, industrial engineering came out of manufacturing. It really came out of steel manufacturing in the early 1900s, and so I'm going to talk a little bit about that because it still actually does relate to baseball. So the father of industrial engineering is this guy, happy guy, Frederick Taylor. He lived in the late 1800s, early 1900s, and he is known as the father of scientific management. And that title, scientific management, is sort of important because later we're going to talk about scientific things like scientific baseball, which is how baseball managers referred to themselves or referred to their outlook on the world back whenever they were managing back in the early 1900s. Frederick Taylor is probably most famous for the shovel experiment. He worked in a steel mill, and in that steel mill, it ran by coal burning 24 hours a day. And there were people that shoveled coal 24 hours a day to make that happen. And they all used the same shovel. For some, it was too big, and for others, maybe, it was too small. So he did an experiment to try and find the optimal size of the shovel for someone to be able to shovel coal for essentially 8 hours without falling over and having some quality of life. Wasn't a lot back then, but there was some quality of life. So he looked at trying to make most efficient this key element in the manufacturing of steel, and that's how he sort of made his fame initially. The next two most important people in the history of industrial engineering are Frank and Lillian Gilbreth. Have any of you read the book or seen the movie Cheaper by the Dozen? Not the new Disney movie, but the old Myrna Loy plays Lillian Gilbreth in that movie. Cheaper by the Dozen is the story of the Gilbreth family. They had 12 children, and thus the name of the book, Cheaper by the Dozen. So Frank Gilbreth sort of worked in parallel to the previous guy who's, I can't believe I couldn't remember his name, Frederick Taylor. He worked sort of in parallel to him. He was a little bit more humanistic in his approach to the world than Taylor was, but he really looked at improving systems and working with people. He worked a lot with bricklaying. They were building a lot of factories and buildings and so forth, and he came up with the most efficient way to lay bricks, and he designed inventions to help people lay bricks and so on. Lillian Gilbreth also was really at the forefront of industrial psychology, how to get people to work, how to get people to work efficiently and happily, and so on, and they worked together for a very long time. Frank died relatively young, and Lillian carried on his work and her own work. She was a PhD in science when very, very, very few women were able to do that back then. They also have a tie to baseball. Frank worked with the New York Giants and filmed them. It was the first videography of athletics, I think, ever, and he did it so that they could see what they looked like, so that they could improve things like their pitching motion. Now, a little bit more modern is this guy, W. Edwards Deming. He brought industrial engineering really into the modern world by looking at quality, by looking at improving systems. He worked with the Japanese after World War I, and is one of the reasons why Toyota and Sony and so forth came to be prominent in the world, because they were high-quality organizations that looked at how to make things best the first time, catchphrases like that, but actually applied and applied well. Deming made a big impact on the world in terms of looking at how to manufacture things so that they can be used for a very long time, so things could be sustainable and so on. Not much of a connection to baseball, though. So when we look at industrial engineering today, some of the phrases that you might come across are lean, or Six Sigma, or stochastic modeling, financial engineering. All of these things really embody what industrial engineering is today. It's a very, very broad field, and it actually does connect to baseball in a lot of different ways. So I'm going to make those connections by first talking historically about scientific management and scientific baseball. Then I'm going to talk about sabermetrics, which is a term that you probably have heard. It sometimes is used derisively when they're talking about how teams are run. It's sometimes used with a lot of, goodwill when looking at how a team is run. We'll get into some of that. We're going to talk about some of the ergonomics as connected to the physics of baseball, and then I'll finish up with some talk on industrial management and baseball management. So in the early days of Major League Baseball officially started in 1876. So really from the 1890s until the 1920s, Major League Baseball was played differently than it is today. You know how there were 7 home runs in the game on Sunday night? Some guys never hit 7 home runs in a career back in the early 1900s, 1920s, because they were using a baseball that was called the dead ball. They would use 1 baseball a game. If it was hit into the crowd had to send it back or they'd be arrested. There was actually a lawsuit about being able to keep foul balls in, I think, the 1920s. So they used this 1 ball through the entire game. It got mashed over the course of the game. Back then, they threw spitballs all the time, and so not only did it get mashed, it got all messed up. They didn't have grounds crews like we have today. They didn't have dome stadiums, so there's a lot of mud involved in baseball. And so this thing would be almost unrecognizable by the end of the game, yet they still played with it. And so whenever it was hit, it was sort of a dead ball. It didn't go as far as these balls today. And I know there's a lot of questions about juicing and the seams and the outside of the ball in terms of what's going on in the World Series and how many home runs. This is the polar opposite of that in terms of how balls were able to be hit. And so they played very differently. They played very differently during the dead ball era because home runs weren't really a possibility, so they needed to do different things. One of the most important men in the early history of management of baseball is this guy, Ned Hanlon, and he looked at how to manufacture, just like an engineer, runs. He looked at how to allow your team to score runs and how to keep the other team from scoring runs. And so they looked at things like place hitting. These are things that we don't really think about today. Place hitting is where you hit it where they ain't, as Wee Willie Keeler, an early baseball player, said. So you would look at the field, and if they were running a shift on you, which they didn't do back then, you would hit it there instead of just trying to mash it right at the shift. So they played a lot different then. They did a lot of hitting and running, an awful lot of stealing bases, because back then it actually was a more profitable strategy. They did a lot of sacrifice bunting. I'm going to talk about that in a few minutes. They played in a very different way than we play today, and they called it scientific baseball, coming from the term scientific management. The most important team in terms of scientific baseball, I know this picture is a little hard to see, was an early team from Baltimore, and on this team had 4 future major league managers who learned from Ned Hanlon, who was the manager of this team, how to manage and how to manage well in this environment that they were all playing in. And so they looked at how to play modern baseball, how to do things that were going on back then, how to play scientific baseball. Now, scientific baseball pretty much came to an end in 1920 for a couple reasons. The most important reason was this guy, Babe Ruth, because when he swung, he wasn't place hitting. He wasn't trying to hit it where they ain't. He was trying to hit it way out there over the fence. And he would hit, in some seasons, more home runs than other teams did because of his approach. Not only was he a big guy, a very strong guy, he also hit with an uppercut. And very few players did back then. He didn't choke up at all. He didn't try and just place the ball. He tried to mash the ball. Another thing that happened in 1920 is a player by the name of Ray Chapman was killed in a major league game when basically he didn't see the ball coming and it hit him in the temple. They didn't wear batting helmets back then. They didn't wear batting helmets until really the 1960s and 70s. Ray Chapman was killed soon after the game. He died. And they realized we can't do this anymore. We need to have clean balls so you can see the ball. We need to not have the spitball anymore because we don't want to have the ball get all gross during the game. We want to enable our players to be able to, not just be able to play, but to survive sometimes. And so the game's rules changed then as well to end scientific baseball. And the home run eventually evolved into a strategy much like we see today. Maybe not as extreme as we see today, but very similar to what we see today. Babe Ruth was a big cause of that, and then some others that fell into Babe's footsteps, like Lou Gehrig and Jimmy Fox, all also were just great home run hitters, and they really changed baseball in a big way in the 20s, so that by 1927, teams like the Yankees were called the Murderers' Row because of all of the great home run hitters that they sent up one after the other who could just mash the ball and hit it up over the fence at Yankee Stadium. Now, there are some other applications of scientific management that we still find in baseball today. Platooning, which is where you use a lefty batter against a righty pitcher and righty batter against a lefty pitcher. That is something that we see today. We see in some of the teams that have been in the playoffs. That's a remnant of scientific baseball. Relief pitching, which is very specialized these days, as you all know. If you watch these games that go on until 20-2, even though they're only 10 innings long, relief pitching is a very important part of baseball today. It wasn't really embraced until the last 20, 30 years, but that's a big deal. Also, even just measurement of things. Pop time is how long it takes for a catcher to receive the ball and get it to second base to prevent a stolen base. You see first base coaches with stopwatches, and they time plays like that. They time the pitcher to the plate, they time the pop time of the catcher to second base, and what they're looking for is how they know their players perform as compared to what the other team can do in terms of their pitching and defense. And so we see some of these things in Major League Baseball today. So now, let me transition to sabermetrics. Operations research, this part of engineering, of industrial engineering, is really very, very similar in many ways to sabermetrics. The term sabermetrics is a little confusing sometimes, and so I gave a definition, the mathematical and statistical study of baseball records. And the name comes from SABR, the Society for American Baseball Research. It was coined by a guy by the name of Bill James, who I'll talk about in a minute. And really, it's anything now that involves the mathematical study of baseball. Thankfully, in baseball, we have a really long history of numbers. When we look at the box score, which was called the mortar of which baseball is held together, was invented by this guy, Henry Chadwick, back in the 1800s. And since then, people have put together a box score so that we could recreate a game using the numbers, knowing what happened in that game, who did what, how well did they do, and then we can compile these things. And we can compile them into those statistics that I talked about earlier, like batting average and earned run average. And so early box scores looked a little bit like this. They had things like errors and assists listed in them. We don't really see those in regular box scores these days. And you'll notice there's nothing on the bottom that talks about home runs. Those really occur today. I really miss newspapers. I really miss, reading box scores in the newspaper. I, bring them up on my phone and I'll take a look at what happens. But it was, and I guess I'm getting old if I'm talking about missing newspapers and looking at box scores, but I do miss that. Now, statistical analysis isn't something that's brand new. Branch Rickey, who most people know because he had the guts and the will to bring Jackie Robinson to the major leagues, he was also very innovative in a number of other ways, including sabermetrics. Branch Rickey hired the first statistician to work for a major league team, a guy by the name of Alan Roth. When Branch Rickey was working in Brooklyn, Alan Roth would send him letters, and the letters would say things like, did you know thus and such batter hits better against left-handed pitchers than right-handed pitchers? And he hits this much better, and he would give him numbers. So eventually Rickey paid attention and hired the guy. In 1954, Branch Rickey wrote an article for Life magazine, which was the most widely read magazine in the country at the time, called Goodbye to Old Baseball Ideas, in which he talked about on-base percentage being more important than batting average, because it really measured how often you got on base. It included walks. It included getting hit by a pitch, and that mattered a lot. He also came up with new statistics like isolated power, which is just looking at extra base hits and using that as a number to compare other batters. So it's not mixing up singles and doubles and triples and home runs. It's only looking at extra base power, doubles, triples, and home runs. One of my favorite quotes of all time is attributed to Branch Rickey. Luck is the residue of design, and I really like this as an engineer as well. If you design things well, it's going to work. It's not luck, we could call it luck, but it's all about design. It's making things work. So when we look at the brief history of sabermetrics, back in the 50s and 60s, in operations research, an industrial engineering journal, a guy by the name of George Lindsay, and I'm going to show you some of his work in a second, published articles. Academic journal publishing academic articles about baseball. In the 60s, a book by Earnshaw Cook, who was a material science engineer, came out, again, about looking at numbers in baseball. In 71, Saber was found. In 1984, The Hidden Game of Baseball by John Thorne, who I referenced earlier, was written. A really nice book that explains some of the early approaches to sabermetrics. Probably most of you have heard of the book, or at least the movie Moneyball with Brad Pitt. Moneyball really brought a lot of sabermetrics to light back in the early 2000s. And just to point out that there's still work going on today, this guy, Travis Salchik, wrote a book on big data in baseball 2 years ago. It's a really interesting book about the Pittsburgh Pirates and how they use big data. So the father of sabermetrics is Bill James. Bill James wasn't the first person to do sabermetrics, but he was the first person to do it well and write about it very well. He began to self-publish back in 1977. In 2003, he was hired by the Red Sox, and it's no coincidence that they won the World Series the next year in 2004. He influenced a lot of their decisions before he got there, and he really influenced a lot of their decisions since he's been there. And I am very happy to say that Bill influenced me. I claim one of the reasons I'm an industrial engineer is because back in high school, I read some of Bill James's baseball abstracts, and they made me think about numbers and situations and management and psychology and people, all of the things that I still think about every day. He also answers emails, and so I've had the fortune, I've never met him, but I have emailed back and forth with Bill James over a few things. Real quick, this is just one formula that he developed, which is called runs created. When we take all of the things that go on in a baseball game, when we take the hits, the steals, the outs, all of the things that happen, we can combine them into different statistics. And that's what Bill tried to do back in the 1970s. He created this statistic called runs created that basically measured how you score runs and prevent runs and combines them. And so he looked at this as a measure of effectiveness. It's not the best, but it is interesting that he was taking these things, putting them together, and trying to come up with new ideas for teams back then who pretty much ignored him. So what I want to do is talk to you about games for this one. Let's see, no, this was last night. How many of you watched the World Series game last night? Okay. So I wrote myself notes, but I think I know this off the top of my head. The Astros were winning 1-0 in the 6th inning. The Dodgers came to bat. And Justin Verlander was pitching for the Astros. He looked really good. The leadoff hitter for the Dodgers, now I need a little bit of notes, Austin Barnes, the catcher, he got a single. So runner on first, they're losing 1-0. It's the 6th inning. If they lose the World Series. The Dodgers are thinking about what to do here. So some classical thinking in baseball management would say bunt him over to second so that we can score him, okay? The Dodgers did not do that. The next batter was Chase Utley, who pretty quickly was hit by a pitch. So now you have first and second with none out, 6th inning, losing 1-0. Now all classical baseball management thinking would say bunt the 2 runners over so that they are now in scoring position and they can score. Because anybody gets a single after that, they're going to score. The Dodgers did not do that. And they did not do that. And the next batter up, Chris Taylor, their leadoff hitter, who probably could bunt the batters over, actually hit a double, scored 1 run, got the other runner to third base. The next batter, Corey Seager, hit a sacrifice fly, gave the Dodgers 2 runs. That's all they needed, and they went on to win the game. Now, had they sacrifice bunted, they would have given up a run. I mean, they would have scored maybe the first run anyway. They would have given up an out. And when you have outs to give up, that's really valuable to a team. And the Dodgers management yesterday said, we don't want to give up an out because of information like this. So this is called the Lindsay's expected runs table. This is the number of runs that a team is expected to score based on situation. And so if you go across the top row, that is if there are 0 outs. So go across the top row to first and second, and you'll see 1.39. That's how many runs the Dodgers were expected to score in that situation, 1.39 runs, runners on first and second and 0 out. If they sacrifice bunt and go to 1 out with runners on second and third, how many runs do they expect to score now? 1.32. Less. They expect to score fewer runs if they move those runners into scoring position. This is older data, but this is very still relevant data. This is showing you that that strategy would be a bad strategy. You are reducing your expected number of runs. The Dodgers needed 2 runs to win that game. They eventually got them. If they had done this, they may not have done that. They may not have scored those runs. Now, this also could be something to be used to decide whether or not to steal second. So if you look at the expected number of runs with a runner on second base and no outs, that's 1.11. But if you compare that to the expected number of runs given no runners on base and 1 out, if you get caught stealing, it goes all the way down to 0.27. And so you see these disparities, these differences in expectation based on what goes on in the game. And so this is what the managers, I believe nowadays, are actually really referencing. They are looking at what they expect to see happen and what actually could happen based on their strategic choices throughout the game. They also may be looking at something called win probability added. So this is the win probability added for the graph for the game on Sunday night. One of the wildest games I've ever seen, one of the wildest games in World Series history, lots of 3-run home runs. Normally what happens is that graph there looks like a straight line going from the middle to the top or the bottom of that chart over the course of a game. In this, it looks like somebody with severe heart problems. What you see is the Dodgers got a lead, and so that line comes down lower, which represents the Dodgers having a higher probability of winning that game. And then the Astros have their comeback, and then the line juts up back to the middle. And then it stays there for a little bit, and then the Dodgers score again. And then the Astros have their comeback again. What you're seeing here on this graph is the probability of winning shifting back and forth over the course of the game. I think there were six different times when a change of 25% in the likelihood of winning occurred over the course of the game, which never happens in any games, let alone a World Series game. And so, again, win probability added can be used to make decisions about what to do. It can also be used to look at individual batters and their performances. This is one of those statistics that I mentioned. You could take a look at how more likely you as a batter help your team to get in the lead to win the game throughout the course of every game, add them all up, and then use that as a way of looking at how best to choose your batters, how best to put them in a batting average, how best to acquire them. So I got a message up here that says my battery is running low, so let's hope that doesn't keep going. So I'm sure it's plugged in. It's okay. I'll get through. Okay, so that's one other sabermetric approach to being able to do that. Now, here in New York, we got to see a lot of Aaron Judge this year, one of the greatest young players I've seen in a long time. This is Aaron Judge's strike zone. So this is from the catcher's point of view. And Aaron Judge is a right-handed batter, so he stands over here. Catcher's here. Aaron Judge is here. This is a graph of where he likes to swing. And you'll notice that he really likes to swing a lot at balls that are high and inside. And he really does not like to swing so much at balls that are low and away. Where would you pitch him if you were a pitcher? Low and away, where he doesn't want to swing, where he's maybe uncomfortable at swinging or where he has a hard time reaching. This graph over on the other side is all of the hits that he had this season, including the outs, and where they went. And so, do they shift on Aaron Judge? They sort of shift on Aaron Judge. Why? Because all those green dots over on the left side of the infield around shortstop are where he hit ground balls. He hit very few ground balls over on the right side to second base. He hit far more on the left side. So yeah, you should shift on Aaron Judge. Where did he hit his fly balls? Everywhere. You don't really shift there. Where did he hit his home runs? So the home runs are the black dots that are the furthest away from home plate. He hit them literally everywhere. He really was just powerful when he hit the ball far, but he did pull the ball whenever he hit it close. This is Mike Trout's graph. So Mike Trout has a different tendency. He likes to hit the ball low and in. He, too, doesn't really like to hit the ball away in the strike zone, but he's a little bit better at covering the entire strike zone. Now, this is his graph. You can see for him, he's even more extreme in hitting ground balls to the right-hand side, to pull ground balls, which is why they shift on him. He also hits very few fly balls to left field. So they do shift away from left field in the outfield. They do work with him there. Now, his home runs tend to all be pulled. I know it might be hard to see black versus blue and so on, but most of his home runs are to right field. And so, again, that can influence how pitchers pitch. The one thing that gets me, when John Smoltz last night was talking about how they should sacrifice bunt and how a lot of the announcers put down sabermetrics and so on, yet, at the same time, when John Smoltz was a pitcher, he was looking at this stuff. This is sabermetrics. It's all sabermetrics. It's not just the new stuff that people think is newfangled and complicated. This is also sabermetrics. It's decision-making. It's strategy. It's how you want to run a game. And so one of the things I love about engineering is that we can take a problem and look at it mathematically. One of the things I love about baseball is we can do the same thing. So let me transition and talk a little bit about ergonomics and baseball. Ted Williams, one of the greatest hitters, said that hitting a baseball is the hardest thing to do in all of sports. I don't disagree. When you're great at baseball, you hit the ball 1 out of 3 times with success. You can't say that for quarterbacks or point guards or anything like that in other sports. So when we look at success in baseball, we really can measure it in a bit of a different way. Now, one of the things that we all know if we're baseball fans is that pitchers get hurt. Pitchers, it's inevitable that pitchers get hurt. And so we look at a lot of different ways to measure and perhaps even prevent how pitchers get hurt. And some of the things that we do and sometimes complain about are things like counting how many pitches a pitcher throws. Why would we do that? Because there's going to be a direct correlation between how many pitches you throw and the stress that you put on your shoulder, your elbow, your arm, your body. There are other measures that have been developed like pitcher abuse points. I don't think they're necessarily in vogue these days. Then there are ways of trying to prevent this, like exercise regimens by looking at biomechanics and how it applies to baseball. Rick Peterson, who used to be the pitching coach for the Mets years ago, he was a big proponent of looking at biomechanics and how it can affect and help pitchers. The physiology, not just working on the biomechanics of things, but on the use of oxygen and so on. All of these things come into play because you have guys like Sandy Koufax, who retired when he was 34 years old. Someone here probably knows better than me. 32 years old? Okay. If he had pitched another 4 years, 6 years, 8 years, when he retired, in his last season, he won 27 games and had an ERA right around 2. If his career could have been extended, he would have obviously put up even greater numbers and been even greater stature in the Hall of Fame. But we were sort of robbed of that because he couldn't feel his left arm anymore after he pitched. And so he didn't want to ruin the rest of his life by not being able to do so. So when we look at pitching today, we look at insanely high velocities that pitchers throw. The top graph is Aroldis Chapman, and this is a graph that I took from Fangraphs of his pitching performance over the course of the year. And I know it's probably hard to see, but let me tell you that those are broken up in 2015, 2016, 2017, and then on the y-axis, the speed of the pitches. And he's throwing very consistently over 100 miles an hour every time. His average this year was 100.2, last year was 101.2, year before was 100.4. No one has ever touched this in terms of consistently being able to throw that fast. Clayton Kershaw, who I'm pretty sure we're going to see in about the 6th inning tonight, this season through 93.1, you see that that's come down a little bit. One of the things you can notice in his graph is there's gaps because he's been hurt. He's the greatest pitcher pitching today, I would probably argue, but he's been hurt an awful lot and has missed a lot of time because of the toll that pitching takes. And so, as engineers, we want to look at trying to improve that system, trying to make it better. It's almost inevitable that every pitcher gets Tommy John surgery these days. If there was a way that you could actually do that or prevent that proactively, anyone would be able to do very well in working with major league pitchers on that. So we look at that. We also look at the physics of baseball. We look at how the reaction time affects how long someone has to bat, which is why Aroldis Chapman is so successful, because he can throw 100 miles an hour. We look at the reaction time, how Jose Altuve can just get the bat around on 100-mile-an-hour fastballs and knock it out of the park. We look at the reaction time of everyone involved and how they affect things. We also look at the physics of baseball in terms of actually flight of the ball. When you look at an airplane stays in the air because of the thrust of the air pushing the plane up. When we look at a baseball, it's pretty much the same thing. The thrust is the force with which the ball is batted. And that ball is going to come in based on the type of pitch, the location, the velocity, the spin rate, which is extremely high, and it's going to travel once it's hit based on the bat speed, the exit velocity, how quickly it goes off the bat, the launch angle, what angle it goes off at, and its spin rate, because spin is put on the ball again as it goes out. When you look at pitching, this is a graph, or this is a table of the average pitch speed for certain pitchers. This is the fastest pitchers in baseball. And you can see things like, again, Aroldis Chapman, according to this, threw 99.7 for his four-seam fastball, just one of the pitches that he threw. You also can see that he extends 6.7 feet from the pitcher's rubber. So he is able, because he's so tall, such a big guy, to really extend and get the ball that much closer to the plate and then travel 100 miles an hour. Noah Syndergaard, equally tall guy, able to extend 6 feet. And so you see some of these things that we can now measure and now look at in terms of how it impacts what goes on in a game. Likewise with batting, we can look at the exit velocity. You heard exit velo is a big phrase this season. We can measure things like the exit velocity. So Aaron Judge led the league with an average exit velocity of 95.3 miles per hour. He was contributing on average 6.5 miles an hour to the speed of the ball coming in by the power of his batting. His launch angle on average was 15.2 degrees, which is different than everybody else here. And on average, he hit the ball 237.8 feet with every hit that he had. This is another, I think I pulled this off of MLB.com. All of these things are measurables that we can take a look at today and are just fascinating. I don't have the time to go detailed into every single one of these things, but again, this is what an engineer really can look at, just like they look at the performance of a jet, just like they look at the performance of any other device that they're creating. They can also look at the performance of baseball. We also take a look at things like material design. This is a replica glove that Babe Ruth used to wear. I cannot catch a ball one-handed using this glove. It just doesn't sit in there. I can barely hold a ball with one hand. So Babe Ruth caught everything with two hands. How many times do you think tonight you're going to see an outfielder use two hands when he catches a fly ball? Maybe never. So that's because they don't need to. They're using modern gloves, much bigger gloves, much more useful. We look at how to design gloves. We look at maple versus birch versus ash bats these days. Ichiro is depicted here. Ichiro, he makes his bats exactly 33.46 inches long, every single one, because that's his optimal size. He also wants all of his bats to weigh between 31 and 31.75 ounces, and if the humidity's high, the bat gets too heavy, and he puts it into a humidor to lower, or he puts it in something that takes the humidity away to lower the weight of that bat. He can tell the difference. He's that particular about batting. Not everybody is. Some guys just throw their bats in a bat bag and are happy. Others, like Ichiro, are very specific about how they take a look at their bats and what it is that they do. Obviously, Major League Baseball is one of the few areas that still uses wood bats, so it's still one of the few areas that we look at in that way. But performance is still something very important as far as we can work with. And again, an engineer can look at how bats are constructed, balls are constructed, and work with how they can be improved. I don't want to even touch the baseball because it's really controversial these days. Is it juiced? Is it too slick? Are the seams too low? All of those things came up. Last night they were talking about how none of the pitchers could throw sliders very well because they couldn't get enough spin on it. Yeah, that's a never-ending story, I think, as far as that goes. So lastly, I want to talk just a couple minutes about industrial management and baseball management. So I talked about the early days when John McGraw and Connie Mack, the little Napoleon and the tall tactician, were running baseball. And now anybody that saw Moneyball knows the guy in the middle, as depicted by Brad Pitt. That's the real Billy Bean there, the Moneyball guy. He really did change and bring to light a lot of what was done back then. And again, things are really being done in a different way today. Major League Baseball is very reliant on analytics. Every team has a department. Every team competes for others. There was even intellectual property issues that occurred between the Cardinals and the Astros last year as a result of secret information being pulled from another team's computers. Strategic management. When the Yankees hire whoever it is that they are going to hire to be their manager, everyone these days is thinking, okay, they're hiring whoever the general manager wants so that he will do what the general manager decrees. Moneyball was all about market deficiencies and looking for batters that could get on base with greater efficiency. That still is occurring today. The Extra 2% is a very good book about the Tampa Bay Rays and how they were run by Wall Street people who looked at trying to get that extra 2% to make them that much better, to make them able to win. I mentioned big data baseball. All of this information that I talked to you about with bat speed and exit velo and pitch speed and all that, that's collected on every pitch, and so it becomes a big data issue to be able to analyze all of this. And so when I'm bringing this all together, when I'm thinking about how industrial engineering and baseball fit together, I think, wouldn't it be great if there was an industrial engineer who is in baseball, who is making things happen, who is running things. And a few years ago, I just happened across the fact that now former New York Yankee manager, Joe Girardi, holds a degree in industrial engineering. Now, I've tried to get in touch with him to talk to him about his background in industrial engineering. I read his biography, barely mentions it. If anyone ever has any connections with Joe Girardi, I'd love to just have a chat with him about industrial engineering, how he used it in his managing with the Yankees, and I'm sure he's going to have another job in baseball managing, and I'd love to see and learn how he actually takes industrial engineering and puts it together in what he does on a day-to-day basis back then. And so, hopefully, in this quick talk, feels very quick to me anyway, I've gotten across to you the connections that I find between industrial engineering, and baseball. some of the depth that we can go into in some of these areas and how we can take a look at baseball in a very scientific, analytical, engineering way, and how we can really pull things apart and look at them and maybe make them better, maybe not better, faster, and cheaper, but definitely better in terms of how they're managed on a day-to-day basis. So I'd be happy to take any questions, and I'd be happy to talk to anybody about any of your questions. I know I've been requested to ask everyone with a question to come on down and talk on the mic, because then it will be picked up on the live stream broadcast. So come on down.
Thank you. That was really great.
Thank you.
Enjoyed it very much. I listen to the sports shows on the radio a lot, and when a great pitcher like Clayton Kershaw pitches as inconsistently as he does in the postseason as compared to how he performs in the regular season, there's always a debate on whether can he handle the pressure. Maybe he doesn't handle the pressure properly, but on the other side they say, well, it's a small sample size, and that's the guy I'd like to have on the mound when all the marbles are on the table. Is there a way to look at his performance, like you say, scientifically, to determine whether he pitches differently physiologically under those circumstances than he pitches in the regular season? Is there a way to analyze that?
Okay, that's a really good question. And one of the things it gets at is the idea of clutch. Do batters, pitchers, whoever, perform better in the clutch when everything's on the table, or do they perform worse when everything's on the table? Clayton Kershaw is a great recent example, because in recent years he hasn't been so good in the postseason. Up until 2 nights ago, I thought he was pretty good this season, pretty consistent this season. He had a bump in the road the other night. We'll see what tonight holds. Is there a way to measure that? Yes and no. Yes, there is small sample size, and I would never judge anybody based on one single performance or even a couple performances. When you look historically, Willie Mays was not very good in the World Series. He never, I guess he did play in some playoffs, but in the postseason, Willie Mays was not a great player. Is there any question that Willie Mays was not a great player? Willie Mays was one of the greatest. Ted Williams was not that great in the postseason. Didn't have that many chances, but wasn't that great. Clayton Kershaw, I think, is like those guys. There's no question that I would want him to pitch for my team if we were playing in the 7th game of the World Series, at least this season, last season, season before. But, yeah, you have to wonder. And I know the psychology of the game is huge, and that is something that's very, very hard to measure. And so taking all of those things, it's a really complicated way to say, I don't know. I think that, yes, I can measure the statistics, but that's not going to tell the whole story. I can look at him and I can see if he looks tense. I can see if he releases the ball at the same point consistently in the regular season and the postseason, and try and compare that. I can even look at how he does from situation to situation. Like Verlander last night, when he had to pitch from the stretch, when he had a runner on base, he seemed to be different. All of those things can matter, and comfort really does matter. Your mind matters an awful lot when you're out there. So I don't know. I used to think that there was no such thing as clutch. Now I think there is something as clutch, but it's not huge, and that's really where I still sit. But I don't know that you can really measure that difference accurately. Okay?
Thanks for the talk.
Sure.
And you obviously talked about this a lot, but there's the clear transition to more of an analytical approach to baseball and statistics and smart baseball and everything. Do you see that trend continuing and taking over? Or do you see any pushback maybe occurring from the quote old guard of just judging players by the eye test and thinking about clutch hitting being an actual thing?
Sure. So on one hand, I would say that boat already sailed and it's already completely analytical. I don't think the old guard has much footing in terms of the old ways of doing things, but I also would say that there is still a lot to the psychology of the game, the approach that you have, the drive that you have, all of those things that are not as easily measured as your fastball speed. And so one of the things that in Moneyball, if you remember, Billy Beane is a really handsome guy. and everybody referred to him as having a great baseball face. He really looked like a baseball player. And so everyone thought that he was going to be a great baseball player because he was built like a baseball player. He looked like a baseball player. He just, he looked like one of these guys on baseball cards. And then he ended up not being so good. And so was there some problem in his makeup? Was it something that was baseball-oriented? Was it psychological? He's a great general manager. He took his teams to the playoffs many times with really low-paid teams. So I think that every team already has a lot of analytics. It's not going to go away. But the thing that I think is going to change things is technology is still going to change things. I'm pretty sure we're going to have robotic balls and strikes before too long. Something's going to happen, and that's going to come to be. I think there's going to be other technological changes, and I think they're going to have to adjust to those things. But I'm pretty sure everything analytic is here to stay.
All right, I have a lot of questions, but I'll just start off by saying that I was down in spring training, and the Houston Astros are really, really heavily involved in the Sabermetrics. But my question is, two-part question. One is, do you think the strike zone is going to be adjusted or have anything to do with the computer systems nowadays as we move forward and the umpire is going to be gone in the game? And then my other question is, and it was kind of disappointing, but the Astros have a guy at each level, each minor league level, that really tells the manager who plays where and who pitches when because of their spin rate, their exit velocity, their everything that has to do with the Sabermetrics. And my question to you is, with that part of it, whatever happens to the Altuves and the guys that don't generate that early on, and how do you project that?
Okay, good questions. I do think that there has to be a robotic or whatever, an automatic strike zone before too long. On one hand, I'm going to hate that because I coach a lot of Little League Baseball, and it's going to make Major League Baseball different in a really appreciable way from Little League. You're going to have people calling balls and strikes in Little League and high school, probably college maybe, and I don't know what's going to happen. And the majors, if there's a robot calling balls and strikes, that's going to be very different. But at the same time, as an engineer, I almost want to say, why not? I mean, it's going to be more accurate. It's going to be more successful at actually calling the balls and strikes. So I do think that's coming. I'm a little wary of that. As far as guys getting a chance when they're not necessarily numbers perfect, I know that's going to be a problem. I know that's always something that's going to be a tug between players. My favorite player in the World Series is Altuve, as you might have seen. I had him here in a couple pictures, mainly because I'd like to think I could be him. Never in a million years, but we're the same height anyway. So I would love to be inside some of those rooms and see them looking at just the numbers, but then also taking their file and saying, this guy does have a different approach, a different mindset. It looks like he's successful. We measure these things in the corporate world. We measure how people work on teams together in the corporate world. We build teams based on personality. We often look at leadership and try to train people to be leaders based on different things. I think the same thing can be done in baseball and give people who do have some skills the ability to do some of those things on a team basis, and to maybe even take other people who may be missing some of those skills or may have losses in the numbers here and there. But I still think the cream rises to the top. So if you are good, you're not going to get ignored by every single team. Somehow or another, you're going to get to the top still. I love the history of baseball, and I love the stories of guys coming across players in the theoretical cornfield and finding them and turning them into major leaguers. But I also know that baseball is serious business, and so money's going to drive an awful lot, and that's going to be a big part of it. And that's why the Astros do what they do. Yeah. Yes?
So I've heard people argue how baseball is being ruined by the massive increase in play time that's going on, how the games are just being dragged on forever, it seems, these days. What would you say about that in terms of like the science of that and like maybe techniques of speeding up games or?
So that's a good question. And so personally, I don't mind if a game goes really long if I don't have anywhere to be, because I sort of like baseball and it's okay to watch a 4-hour game. The other night was pushing it. At 1:30, I was thinking this could just end now. That would be okay with me. But I can see there being rules that would maybe limit pitching changes, because if it's going to come down, which I do think that starting pitchers are going to be lucky to go 4 innings before too long, I do think that as that trend becomes more popular, they might put a limit on how many times you could switch a pitcher in an inning or something like that, or limit you within a game and add some strategy there. The one thing that they have to avoid there is somebody getting hurt by being stuck and having to pitch too long, but I can see that happening. Doesn't really have to do with numbers, it really just has to do with attention span. On the other hand, a lot of the other stuff, they don't enforce all of the rules. So if you take an umpire away from behind home plate, it's going to get even worse with batters stepping out, or how they're going to even enforce that, with pitchers stepping off, with the catcher going and talking to the pitcher every couple pitches. So a lot of those things could be enforced in a different way and make the game a little bit shorter. That is still, as I view it, an engineering problem, because it is still something that could be improved, and we would have to look at a lot of different ways to do that. But that's not so much a skills question as it is a management question. Yeah, agree.
Thank you.
Sure.
With the analytics have changed. The analytics have changed, so you've got a lot more home runs. Do you think the analytics is going to change it back a different way? Because now you have, with all the chart, the charts of where the hits are going, a player like a Rod Carew, for example, who was a good player when I was a kid, would hit 700 because he could place the ball. So maybe hitting where there ain't is
Could
actually
come back.
going to revert.
I would love to see that. The thing that surprises me is Jose Altuve hits a lot of home runs. So he would be, the guy that you would think would be the place hitter. He would be the guy that would be able to do that.
Yeah, he's a different type of player. He's a player like, again, when I was a kid, there's a guy named Jimmy Wynn.
Sure.
Who played for the
Joe
Astros.
Morgan, yeah.
Very similar size.
Yeah.
Matter of fact, he even might have been a little smaller than Altuve.
Yeah.
But
Yeah.
he was as wide as Altuve, and he hit home runs. But because they're spacing the players out differently, the fielders out differently, and so many pitchers are throwing fastballs, that what I expect to see happen in a couple of years is you're going to see a lot more curveball pitchers.
Yeah.
You're going to
Which
see a
happened
lot
this
more
year
jump
already.
ball pitchers
Yeah.
because players aren't going to be able to, they're not going to be used to it. And you're going to see a lot more single, double hitters that are trying to just place the ball.
Well, so 2 years ago, the Royals won 3 years ago, the Royals won the World Series? Was
No,
it
they
2
won in
years ago?
50 and they
2
beat the
years.
Mets.
Okay, yeah. So they did that. They were mainly a maybe not a place hitting team. They were not a home run hitting team. And they won the World Series. And a lot of people thought, okay, this is going to be the change. There's going to be a trend. And it ended up being a blip instead of a trend. Still, they showed that you can win that way. You can construct a team that way, and you can win that way. I think the Astros would be that kind of team if they played maybe in a different stadium. They play in a very hitter-friendly stadium, but most teams do. That's one other thing that has really changed the game, even since the 70s when Jim Wynn and Rod Carew were playing, is stadiums are a lot smaller, and so it's much easier to hit home runs, so why don't you? So that's the one thing going against your theory is you got to change the environment to make it so that that can be more
And I
profitable.
think pitchers will change. And I think what Houston is seeing now is Houston, as you said, is they're built for that park.
Yeah.
They really are.
Yeah.
Once you take them out of that park, at least in the postseason, they're a completely different team.
True.
And unfortunately, it makes
On the
them
other
back
hand,
on.
though, they won 102 games
No,
this year.
I understand.
So they
that.
won a bunch on
obviously
the
had to
road.
win some on
Yeah.
the road. But postseason, they have been a completely different team.
True, true. Well, I would love to see a variety. I would love to see more variety because I do fear that just hitting home runs is going to get boring. So I would love to see variety across the board and a lot of different things, and I think the sport probably needs it also.
Thank you.
One last question?
Yes. This year, the Mets fired their strength and training director because he was held accountable for all the injuries that the Mets had over the last
Yeah.
2 years. Is there any way that your industrial engineering can determine whether these injuries were just an unfortunate series of coincidences or whether there's something that they were doing to contribute to this host of injuries over the last 2 years?
So my gut reaction is to say absolutely there's a way. and where there's smoke, there's fire, and you don't need an industrial engineer to know that. But at the same time, you know, there are different professional approaches to how to be ready to play baseball, and it's changed wildly over the years. On one hand, Babe Ruth never worked out at all during the season. He never lifted weights. He did things, you know, there's pictures of him using medicine balls and things like that. And in the 70s, players didn't do what they do now, and now they have personal chefs, and they have strength and conditioning year-round, and they do a lot of really proactive things to try and stay successful. Yeah, I think some teams have been far better at that than others. The one area where no team seems to be bulletproof is pitching, because every pitcher gets hurt, and it doesn't matter if you're the Mets with every pitcher getting hurt, it seems, or the Yankees or the Dodgers or whomever, your best pitchers get hurt. And so that seems to be almost something that's not preventable, but I think a lot of the other things definitely are, yeah. Yeah.
Thank you. Thank you.
Okay.
Well, thank you all for coming. Big thanks to Ray.
Thank you very much. Have a good night and enjoy the 7th game of the World Series, everybody. Good night.